30 inorganic reactions. I will teach you super easy tricks to learn 30 important inorganic reactions in a very short period of time. First of all, let me teach you 4 important reactions. Let's consider these reactions. Now I will use my personal tricks to solve these important reactions. The first reaction is an exception case. I leave it for a moment. In case of the second reaction, we know that sodium is from the first group. I say sodium is the first element. Secondly, I say sulfur is the second element. Now listen carefully. The first product of the reaction is first plus second elements. We know that the first element is sodium and the second element is sulfur. I write sodium and sulfur. The oxidation state of sodium is +1 and that of sulfur is -2. According to crisscross method, I write here 2. Thus I get sodium sulfide. Now what about the second product? It is super easy. I write this first product, sodium sulfate, as it is. Here is oxygen in the reactants. So I write O3 with the second product. Thus when sodium hydroxide react together, we get sodium sulfide and sodium sulfite. Now in case of third reaction, I say sodium is the first element and halogen is the second element. According to the trick, I write first element and second element. The first element is sodium and the second element is halogen. We know that the oxidation state of sodium is +1 and that of halogen is -1. Thus I get NaX or sodium halide. Now what about the second product? Well, according to the trick, I write the first product as it is. We can see that there is oxygen in the reactant. I write here O3. Thus remember that when halogen reacts with sodium hydroxide in hot conditions, we get sodium halide plus sodium halide oxide. In case of fourth reaction, I say sodium is the first element and halogen is the second element. According to the trick, I write first and second element. Now what about the second product? According to the trick, I write the first product as it is. We know that there is oxygen in the reactant. I write here O3. But wait a minute. Here the condition is cold. So I say sodium halide. So instead of O3, I only write one atom of oxygen. Thus remember that when halogen plus sodium hydroxide react together in cold conditions, we get sodium halide plus sodium halide oxide. Now in case of the first reaction, being an exception case, I say phosphorus is the first element and hydrogen is the second element. According to the trick, the first product is first element and second element. The first element is phosphorus and the second element is hydrogen. The oxidation state of phosphorus is +3 and that of hydrogen is -1. According to crisscross method, I write here 3. What about the second product? Well, we know that in the reactant, there is sodium and oxygen. I take this pH3. I remove one hydrogen from it to create positive and negative side. I get H2P. Now the positive side is filled by the sodium and the negative side is filled by O2. Remember that the subscript of both hydrogen and oxygen is 2. Thus when phosphorus plus sodium hydroxide react together in hot conditions, we get pH 3 or phosphine and sodium hypophosphite. Hence noted down these 4 important reactions. Now let's consider these 2 reactions. Pause the lecture and try to figure out their products. Well, according to the trick, sodium is the first element and chlorine is the second element. I write first plus second element. I get sodium chloride. In case of second product, I write sodium chloride as it is. There is oxygen in the reactant. I write O3. Hence these are the products of the first reaction. In case of the second reaction, I get sodium chloride. I write this sodium chloride as it is. In the reactant, there is oxygen. I write O3. But wait a minute. The condition is cold. Hence I say less oxygen reacts with sodium chloride. I write only one oxygen atom. Hence these are the products of the second reaction. Thus noted down. Now we will learn 5 important reactions of hydrolysis of xenon fluorides. Let's consider these reactions. I will teach you common tricks to crack these 5 reactions. I leave the first and the second reaction. Remember that in all these 3 reactions, hydrogen fluoride are formed. In case of the third reaction, I write hydrogen fluoride. In the reactants, there are 2 hydrogen atoms. I write here 2. What about the second product? Well, there is 1 xenon in the reactant. I write here 1 xenon. Secondly, there is 1 oxygen in the reactant. I write here 1 oxygen. Thirdly, there are 6 fluoride in the reactants. I have already written 2 fluoride in the products. So I write here 4 fluoride. Thus these are the products of the third reaction. Now I will repeat this trick for the fourth and for the fifth reactions. In case of the fourth reaction, I write hydrogen fluoride. We can see that in the reactants, there are 2 into 2 is equal to 4 hydrogen atoms. So I put 4 with this hydrogen fluoride. What about the second product? We can see that in the reactant, there is 1 xenon. I write 1 xenon. There are 2 oxygen. I write O2. There are 6 fluoride. But I have already written 4 fluoride in the products. I write 2 fluoride here. Thus these are the products of the fourth reaction. In case of the fifth reaction, I write hydrogen fluoride. We can see that in the reactants, there are 3 into 2 is equal to 6 hydrogen atoms. I write here 6 with hydrogen fluoride. The second product is, we can see that there is 1 xenon in the reactant. I write here 1 xenon. There are 3 oxygen in the reactants. I write O3. There are 6 fluoride, which I have already written at the product site. Thus these are the products of the fifth reaction. Remember that the first and the second reactions are exception cases. In the first reaction, 3 products are formed. And in the second reaction, 4 products are formed. To balance the first and the second reaction, I write 2 and 6. Now these 2 reactions are balanced. In case of first reaction, I write hydrogen fluoride. In the reactant, 2 into 2 is equal to 4 hydrogen. I write 4 with hydrogen fluoride. Secondly, in the reactant, there are 2 xenon. I write 2 xenon. Thirdly, in the reactant, there are 2 oxygen. I write O2. Thus these are the products of the first reaction. In case of the second reaction, I write hydrogen fluoride. There are 12 into 2 is equal to 24 hydrogen atoms. I write here 24 with hydrogen fluoride. Now listen carefully. In the reactants, there are 6 xenon. I divide it into 4 xenon and 2 xenon. I write 4 xenon and 2 xenon here. On the other hand, there are 12 oxygen in the reactants. I divide it into 6 oxygen and 6 oxygen. I write here O3 and 3 oxygen molecules. Thus, these are the products of the second reaction. Therefore, using this simple trick, we can easily learn these 5 important reactions. Now we will learn 20 important reactions. The first 5 important reactions are D and P block elements reacts with KMnO4. We know that KMnO4 is a good oxidizing agent. It oxidizes other species by increasing its oxidation state. For example, consider these reactions. The common trick is, if the element is from the D block, just increase its oxidation state by 1. Secondly, if the element is from the P block, increase its oxidation state by 2. Also remember that in all these reactions, Mn plus 2 ion is produced. I write Mn plus 2, Mn plus 2, Mn plus 2, Mn plus 2 and Mn plus 2. Now in case of the first reaction, Fe is from the D block. According to the trick, I increase its oxidation state by 1. I get Fe plus 3. Secondly, Sn is from the D block. According to the trick, I increase its oxidation state by 1. I get Sn plus 3. Thirdly, nitrogen is from the P block and its oxidation state is plus 3. According to the trick, I increase its oxidation state by 2. I get NO3. Here, the oxidation state of nitrogen is plus 6. Fourthly, sulfur is from the P block and its oxidation state is plus 4. According to the trick, I increase its oxidation state by 2. I get SO4. Here, the oxidation state is plus 6. Lastly, sulfur is again from the P block and I increase its oxidation state by 2. I get SO4. Thus, using this simple trick, we can easily learn these 5 important reactions. Now we will learn 5 more important reactions with KMnO4. Let's consider these reactions. We know that KMnO4 is a good oxidizing agent. It oxidizes the given species by increasing its oxidation state. Remember that in all these reactions, Mn plus 2 ion is produced. I write Mn plus 2, Mn plus 2, Mn plus 2, Mn plus 2 and Mn plus 2. In case of the first reaction, chlorine ion is oxidized to chlorine gas, bromine ion is oxidized to bromine, iodine ion is oxidized to iodine. In case of the fourth reaction, H2S is oxidized to sulfur. In case of the fifth reaction, oxalate ion is oxidized to carbon dioxide gas. Thus, using this simple trick, we can easily learn these 5 important reactions. Hence, note it down. Now we will learn 5 more important reactions of D block elements with potassium dichromate. For example, consider these reactions. We already learned the trick. If an element is from the D block, its oxidation state is increased by 1. If an element is from the P block, its oxidation state is increased by 2. We know that in all these reactions, chromate ion is produced. I write chromate ion, chromate ion, chromate ion, chromate ion and chromate ion. Now in case of iron, it is from D block. I increase its oxidation state by 1. I get Fe plus 3. Secondly, Sn is also from D block. I increase its oxidation state by plus 1. I get Sn plus 3. Thirdly, nitrogen is from P block. I increase its oxidation state by 2. I get NO3. Fourthly, sulfur is from P block. I increase its oxidation state by plus 2. I get SO4. Lastly, sulfur is again from P block. I increase its oxidation state by 2. I get SO4. Thus noted down these important reactions. Finally, we will learn 5 more important reactions with potassium dichromate. Let's consider these reactions. We know that potassium dichromate is a good oxidizing agent. It increases oxidation state of other species. We know that chromate is formed in all these reactions. I write chromate ion, chromate ion, chromate ion, chromate ion, and chromate ion. Now chlorine is oxidized to chlorine gas. Bromine ion is oxidized to bromine. Iodine is oxidized to I2.